Hello, beautiful humans of the internets. It is I, Deadprogram, your favorite, cyborg. Sure. Hello, fellow cyborgs. Hello, robots. And especially, hello, extraterrestrials. Send us a sign. We just want you to blow our minds. Yeah, as the David Bowie lyric goes. So here I am at beautiful La PIPA in Asturias, Spain, with my trusty colleague, GoBot. What was that, GoBot? Yes, GoBot says that now that we have been vaccinated with the Moderna vaccine, since we are very modern creatures, hopefully it will not be too much longer before we don't have to be masked up all the time, just most of the time. So, it's been quite a week with lots of fun action. And let's talk about a little bit of news. Naturally, last week's news was the all-important interview with yours truly in GoLang Weekly. Thank you very much. But interestingly, there was a part of this that actually resonated with a few people. What has been the most surprising, interesting use of TinyGo? Well, people running TinyGo on older, less powerful hardware. Here's the clip. The recent chip shortages and supply chain issues mean that we have to do more with the hardware we've already got. Well, it just so happens that even Tech Republic and others have been covering this painful global chip shortage that we've been going through. And interestingly, they say that it's going to affect more than just your laptop and your automobile and your toys, of course. So, interestingly, one of the statistics was that the automotive industry has been substantially impacted, but additionally, other areas of technology such as computer networking. So yes, we must do more with what we've already got, which is a key part of the whole value proposition of things like TinyGo. Languages that are very small, very compact, and very powerful. Anyway, on the opposite side, doing some really interesting things this week, Oxide Computer, company run by a few friends of mine who are deeply involved in the Rust programming language, they finally put their website live, and we have a little bit of an idea of what they're up to. Kind of the opposite of the global chip shortage philosophy. Their idea is to build very high-end server hardware powered from bottom to top, all using Rust. So that's pretty interesting. I'm really looking forward to seeing what they come up with. The website looks cool. The concept is great. And who knows, maybe we'll do something kind of like that with TinyGo. Closer to Earth, interesting company that I have heard about because they just raised a round of funding is Heirloom Carbon. So they are involved in technologies for carbon sequester. And obviously these are topics near and dear to all of our hearts who like doing things on planet Earth like, for example, living. So yes, check out our Heirloom Carbon. It'll be interesting to see what they actually have once it's a little more public. So this week, the first TinyGo book is now officially out. Tobias Thiel, contributor and cool human being. Their book, Creative DIY Microcontroller Projects with TinyGo and WebAssembly, is now finally out on Pact. So please go check it out. Get a copy. It's the first book and at the present only book about TinyGo. Who knows how long that will last, but it looks really cool. There's also a whole series of YouTube videos here with all the different things. Well, I don't think all, but a bunch of the things that are in the book. So it looks really interesting. Looking forward to checking that out. And then a bit of interesting news from the Red Planet. So Mars Ingenuity, which is one of the most interesting multicopters the first multicopter operated on another world. Another world. Yes, so I think it was their sixth flight. Yes, the sixth flight, things did not exactly go as planned. In fact, this GIF is really cool of the last 29 seconds. So you can see that the rotors are turning. All of a sudden, whoa, the ground came up really quick. So this was the part that I thought was especially interesting. JPL traced the cause of this glitch to the loss of a single image in the pipeline that Ingenuity uses to estimate its speed and position. So one image lost in the computer vision pipeline and near disaster on the red planet. Whoa. So it just goes to show you that computer vision's not so easy, is it? On that, I should bring my friend Manuel, who has been working on the... First, I must find my mask. It's probably on the ground. Yes. I have a spare. Not to worry. I have mask will travel. That's my motto. So Manuel's been working on the cow tracker, and I think some progress was made. I don't know. Let's find out. Manuel, how's it going, man?
How's it going, Ron? Thank you for having me.
Yeah, so you've been doing some work on the computer vision system for cow identification.
Yes, if you recall, the last day I showed you how the TensorFlow model already detects some other objects, but it doesn't really detect cows or anything else that rate. So I tried to use those weights to retrain the model, just so to save training time, and try and, with a small data set of cow images, try to retrain it using TensorFlow, just so we can run it on GoCV.
So a small data set of large cow images.
Yes.
Images of large cows.
And images.
I guess all cows are large.
Well, yes, I had small and bigger cows, and I also had small cows with photos taken from drones as well, just so it can have some variety.
Nice. So how did it go?
Well, I was able to follow the whole TensorFlow API for object detection, and I got to the part where I got the model, the protobuf model, which is one of the two files that you need for GoCV to run. But if you recall, you also need a configuration file, which basically tells the program, yes, you have these weights and this model, but that model is built this way.
So one is the actual model itself, and the other is like a definition of what's in the model.
Yes, more or less. And the problem is that once you change, for example, the number of classes, you can't use that file, that configuration file that you have, for example, on the GitHub that we were using on the Go program, if you recall. So you have to generate a new one.
Because you've changed. Excuse me. Yeesh. So you've changed the definition of what's in the model, so you need to change the config file to match?
Yes. For example, I changed the number of epochs and all of that just so it trained in less time just to see if it worked. And, for example, the number of classes, because if you recall, the previous model had 90 classes, and we just need one of them. We just need it to detect cows.
Yeah, because it detected all these other objects that you discovered it could detect, but none of them were cows, of course.
Yes, and a bottle was a knife, so, for example. So the problem that I came with was that all of this is built on the TensorFlow API. And the TensorFlow API was updated, and now it's, I think, TensorFlow 2.5, which is the latest version. But OpenCV really works with all those tutorials that you can find online until TensorFlow 1.15. So most of the functions are either deprecated or they just are removed. So some, for example, in these, there are some files in the source repo where you can input your protobuf file, and then it can generate that config file automatically. For example, if it's an SSD model, then you have a TF text graph SSD, for example.
So it reverse engineers the definition from the actual model.
Well, you don't just pass the model. You pass the model, and then you pass the pipeline config, which is this other configuration file. But the issue is that that model doesn't work because maybe 90% of it is made up of functions that don't exist
Ah,
anymore.
so it's been deprecated.
Yes, and it seems like a big issue. So I tried to migrate to cafe models, but I haven't really done much on that yet.
So we may end up with a bespoke cow identification model after all.
Yes, and I
Totally
think,
customized. HL in Asturias, made in Asturias.
yes, and I think it's really interesting that we can do that and use these models that are pre-trained just to save some time in the training. If we were to just do the model from scratch, then it would probably take a lot of hours, unless we had a really nice GPU. Which
Nice
I,
GPU.
Which I don't. So
Yes, nobody has GPUs these days. Well, we'll try to see if we can do something about that. Well, very cool. So what's the next step? Work on the training and then try to, or take a different approach?
Yes, my idea was just train it with a small model and then test if it worked. And then once the pipeline already worked, then I could just input some more images and try a model which was trained in more time, check the loss, see that it predicted correctly, and just follow that whole process.
Got it. Well, very interesting. Well, so maybe you'll have a demonstration of the pipeline next week, if nothing else. You could show us.
Yes, if nothing else goes wrong, then probably I'll have something to show.
Or maybe even a fully trained model.
Well, maybe. Depends on the time.
Maybe. We'll see. Well, cool. Well, thanks for stopping by and keep going. It sounds like some progress is being made. Keep moving.
Thank you.
All right. All right. Thanks
Bye.
for coming. Ciao. Cool. Yeah, no, it's a lot of work. The black art of training models. It's not a black art. It's just science. There's a lot of math. And, of course, a lot of input data. And, of course, human beings saying, yes, it's a cow, and no, it's not. So don't worry, humans. There will be work for us in the future. Cool. So, also my friend Lorenzo is down here, and I know he's been working with us every week on the Learning to TinyGo. And we made some progress last week. We got both a button and an LED, and who knows what's coming next.
Hello.
Lorenzo, what's happening, man? How you doing?
I'm fine, thank you.
Cool. So you got your computer. You have a cool mechanical keyboard.
Yes.
But
yes,
show us the keyboard here. This is.
Let's see if it works.
I like the colors.
Yes. Well, you can change them as well.
Well, yeah, of course. It's all about LEDs everywhere now, right? All LEDs all the time.
Yeah, I love them, especially when working at night with dim lights and things like that. I love it.
So last time we ran into a problem with the here, GoBot, you got to move over here. Ran into a problem with programming the Arduino using the BASA bootloader on Windows, and I don't think we've ever actually reported the bug to the people on the TinyGo team to fix.
No, it was done on the wrong repository on Bosac, but it was a TinyGo probably issue. I think we should do the same on TinyGo.
I'm sure that's where the problem actually is. I don't think. Oh, we're just seeing a screen. Or maybe you have to. Because I was seeing something before. Yep, there we go.
Sorry.
Yeah, no worries. I fell asleep.
That's it.
All right. So, I guess maybe the first thing we should do is try to tell people about, or try to report that bug, don't you think? Because that way we can maybe try to get it fixed.
As you wish. Well, I don't have the screen for the capture. Let me do something.
We don't have to. You don't have to capture. I think if we were just to
run, you mean the?
I think if we just go to the website for the repo and we just enter an issue with the error message we got, that would probably be enough, right?
Okay, let's TinyGo.
Yeah, if we go to the repo.
Okay, so it's a link on the repo, I guess, here. So.
Ooh, dark mode. He's a hipster.
Yes.
So yeah, I think we should enter the issue probably, but that way we have a chance. And I would probably say Windows, and then unable to flash Arduino Nano 33.
Okay. Oops.
Something like that.
The thing is that I wanted to paste now the
Well, yeah.
message.
Well, we should go back to and try the flash it and see the message, and that
Okay.
way we can copy and paste it, right?
Let me see if I can find the.
Well, we could just run the program and it will fail in the same way, I assume.
Okay, now I have to find the project TinyGo.
Wait, what is that? That looks really neat.
Yes, it's my organizer. It's the brain maps.
Mind
Those
maps,
kind-
yes.
And I have a markdown page where I can take notes. This is the free version. So it has some limitation, but at least, for example, you can attach some document and also use it to take notes. And it's quite nice.
That's
to
very
work with.
cool.
Yes, I
Mind
like it.
mapping is really an
I
interesting
think
technique.
Yes, it's very natural, let's say. It doesn't get clogged sometimes, but if you do a proper organization, it will help a lot. And
As long as you have a mind, then you can have a map.
exactly.
That's what stopped me,
The-
generally.
yes, the prerequisite for it.
Of course.
So flashing was TinyGo build target. No, TinyGo flash.
Exactly.
Well, you tell me the.
Yeah, so we can go.
exact
Yeah,
command, so
we can just go to the
and write it down.
terminal.
Okay. Okay. TinyGo.
So TinyGo
flash.
flash space dash target
Dash target.
space Arduino
Arduino.
dash Nano 33,
Okay.
and then the name of the program, which would be, I guess,
Step. No.
what was it called? Step. Really, it could be any step.
Yeah. Okay. Let's do step 0. Do we need the extension or it's enough? Like
Well,
that?
we have to tell it the directory of where to find it, right?
Because this is the. Okay. So
So go back because we have to give it the name.
the output.
So space. Well, no, output is if you want it to build but not
All right.
flash. This is to say, this is the program we want to flash.
Okay, I forgot.
So it would be, I guess, under. I guess it would be
Document.
dot backslash. Is it backslash or full? Yeah, backslash and then step,
Where are we?
whatever it is.
Step
0, that's
yes.
fine. And I think if you just hit
No,
return, it should
let's try.
try to flash everything in the step 0 directory. And then we actually plugged into. Yeah, we have to plug in.
Yeah, yes, first. Sorry.
No
I
worries.
forget those things every time I have to read it. I don't have a good memory in that sense.
So it's still compiling. And then it should give us the error message, whatever that was.
Maybe we did it without flashing, without connecting it, so...
Well, it would say unable to find any device if it can't find any. So it's just probably taking a while to compile.
Okay.
It's a lot slower to compile than it is to execute.
Yeah.
Our priority is speed of execution.
Rather than, yeah. I mean, it's... Okay.
Yeah, BOSAC
that's
extra
the
arguments
one.
found,
So
exactly. So if you copy, yeah,
With a screenshot or text?
I think text is fine.
Okay. Let's go.
If you can successfully copy and paste the text in
Yeah.
Windows.
And okay, I guess this is...
And because you're in Markdown, so if you hit the 3
yes.
and then return, yeah, exactly, and then on the bottom of the whole thing,
Yeah, when you are previewing it right now, it doesn't show up, but I guess it should pick it once we submit. And
Well, you can see preview on this show.
yeah, you're right. Yes, that's it. And
But you might want to also format the output.
oh,
So if you click on right,
yeah. Okay, so everything. Let's put everything in here.
yeah, that's a good way.
Okay. Looks clean enough. Do you think that's enough, or do you
Yeah,
want me to?
I think that's enough.
Okay, let's do just the error message. That's all. Submit new issue.
So this way, at least there's some record of the fact that this problem exists, and then maybe somebody could take a look at that. Cool. So I think we're on step 4.
Yes.
So what was step 4?
Was the I think a touch sensor and a buzzer, if I'm not wrong. Okay.
Well, let's go and look at the actual content for the website, which was on the GopherCon 2019, the last time we got to do this live. And yeah, I think if we go down and we can see that step 1 was the blue LED. Step 2 was a blue LED and a button. Step 3 was the blue LED, the button, and I guess the green LED. Oh, it looks like you plugged in some more stuff.
Yeah, no, well, yes, it's just the capacitive and well, the touch sensor and but I haven't connected just to do it here.
Got it. So I guess step 4 now was the blue LED, the button, the green LED, the buzzer, and the touch sensor. Whoa, we had 2.
No, I'm trying to see if. Okay, let me see. Okay, let's see if it works with the previous. Okay, so we can just.
So yeah, step 3, which was the blue LED and the green LED,
Yeah.
we can see is working. When you click on the button, it turns on blue, and when you release, it turns on green.
Exactly.
So that's good. That's working. So now we're on to step 4.
Okay, so step 4 was we have 2. Well, let me pick those 2 new devices. The Grove. So this is a buzzer. It should beep, and this is a capacitive. Well, it's a touch sensor. I guess it's.
Yeah, but exactly. This is the buzzer, which is your basic piezoelectric, makes a nasty noise to let you know you've done something you shouldn't do. And then, yeah, the other one, exactly, you are correct. It is a capacitive touch sensor that just detects, the change in the current from you being connected to the ground. So it just takes a little tiny change to touch it, and it acts like a button, basically.
Okay. So should we keep everything else connected as before?
Yes, all of the steps in this are additive. You just add more things until we get to the end.
Cumulative, okay.
Cumulative, yes, exactly.
I will power them first if you are okay.
That sounds good.
Okay, so I will put the negative into the negative rail, positive into the positive one, and this one is showing it's active, I guess. There is
Yeah, there's a little LED that comes on that it's getting powered.
Exactly. So now we go for powering the buzzer, positive and negative. Some say some positive. No. Okay. And okay, I think we need to choose the output.
So now we
the
need
input pin, I guess. For
exactly. So I guess now the yellow pin from the touch sensor should go into pin D9.
D9. I think 10 was the last one we used. So if I'm not wrong, the picture.
So yeah, the picture.
So it's the one on the right of the last one we connected. And you were talking about the
Yellow.
sense.
Exactly.
The touch sensor. So yellow, the signal goes here next to number 10. I guess it's this one. I cannot see properly, so I'm sorry. I hope I am right. And this is one. Now we connect the buzzer, I guess, onto pin 8.
So the buzzer, yellow, should go to pin 8. Exactly.
Okay. So here we have it. Pin 8. So I guess everything is connected now. So it's just
Hopefully so. All right, so let's go take a look at the code. I guess, let's see, this is step 4. So step 4, let's see what we got going here. So we got package main, same as before, as the previous step. We're importing the machine package, the time package, and now we're importing another package, the buzzer package from the TinyGo drivers repository. So we have a separate repository that contains drivers for different sensors, displays, also different devices, peripheral type devices that you would want to connect to a project. And so the buzzer is one of those that lets us, make different bleeps and blops.
Can we have a look, or it's too complicated to dive into?
Well, let's look at this program first and make it work, and then we'll go take a look at the buzzer.
I would like to, yes.
So our main program, so we define our blue LEDs on pin D12, and it's an output pin. Our red LED is on pin D10, and it's an output pin. Our button is on D11, and it's an input. Our touch sensor is on pin D9. It is also an input. And then our buzzer is on pin D8, and it is also an output.
So it's just an on-off button. There is no level of input from the capacitive sensor, right?
That's right.
Okay.
So it's just a on and off. And then here we're going to say that our buzzer :equals, so we're both going to define it and assign it, is equal to the buzzer, which refers to our buzzer package, .new, and then we're passing it the pin. So this is saying create a new buzzer driver and use this pin in order to control it.
Okay.
Then our for loop is very similar to how it was before. It says forever, that if the button is off, we turn off blue and on red. And if the button is being pushed, we turn on blue and off red. And then the touch sensor, if you touch it, then the buzzer will go on, which should make a noise, or else it should turn off.
Okay.
And then sleep for 10 milliseconds to give a chance for whatever else in the system. So let's go and see if we can successfully flash this program.
Sorry, I don't remember the command. Sorry, I'm going to.
So we have to do two things. Yeah, exactly. Nothing wrong with taking notes.
Okay. So, well, the path is set, and the only thing is, do we have to move? Well, on the directory we are in, and I guess we need to run the BOSAC.
Well, we have to build
okay.
the hex file first.
So
Or bin
that's
file.
with BOSAC,
Is it the
no?
bin? Yeah, bin. We have to build the binary file with TinyGo build to compile it, and then we use BOSAC to do the flashing.
Oh, so, okay, so BOSAC is the flashing, so there is a mistake here. Target arena now. Let me correct it so I will have it for future reference.
Yes. Good. That's the thing about mind mapping.
Yeah.
They tell us all the things we used to know when we were so much smarter.
Exactly.
And they let us get back to that same place.
So now that I have this one, well, I'm not trusting, so I don't want this to start without, because sometimes it adds the carriage return, which is...
Yeah, then suddenly you didn't want to execute, you wanted to edit it first.
Okay, so it's step 4.
And then the output, you should make step 4 named also
yes.
as well, right? Just that way we...
Step 4. And okay, TinyGo build, target, Arduino, the platform. Output is the binary object, and step 4 is the directory.
Exactly. So that
Okay.
should work.
Okay,
Let's find out.
go get
Wah.
TinyGo driver bus.
Ah,
we have to.
Okay.
Interesting. Sorry.
Yes. So
Get,
now we need, it actually tells you what you have to do.
it's
So in Go, there's a command, go get,
beautiful.
which goes and gets that package and adds it to the packages that are installed for this particular
So it's like
program to be able to get to it. So it's a package management.
okay, go get TinyGo. Boom boom.
So that should go and download it from our drivers repo, which it appears to be.
We have connection. Is package machine.
That's okay. That's because the machine package is not actually a normal package. It's part of the TinyGo compiler. When we compile a TinyGo program, the machine package is the hardware abstraction layer that lets us have an API to communicate with the actual hardware. But it's not just a normal Go package because the TinyGo compiler has to actually take that and translate it to the registers and the values in the hardware itself. So the Go package manager can't install a package named machine because there is no package named machine to install. It's part of TinyGo.
Okay.
But that's okay. It's already installed the driver. So now you should be able to up arrow and try it again.
TinyGo build target. I think it's correct. And again. Something. Go downloading.
Well, here,
it's
type-
a version.
Well, type dir. So you have a Go mod file.
What should
So
I
it
do?
should have, so when we said go get, it should have added it to the Go mod file,
edit. Huh?
or add. So that file, if you were to output the Go mod file, if you were to just echo or cat,
I think it's.
type, yeah, that's
I'm
it.
not sure. I don't. I have such a.
Yes.
Yes, it's the one.
So you'll see that it doesn't know about any actual dependencies, right? So what we needed to do actually is if you hit up arrow to the go get command, and now if we just, instead of just saying go get, if we say go get dash D
If we
space dash U, that will say D for download it and the dependencies, and then U for updating it. It should add it to our Go mod file. But it didn't actually add it, it would appear.
TinyGo.
But it should have if we type the go.mod file. It didn't actually add it.
Changed. No.
I'm not sure why it didn't do that. Because normally it would add it because we're in a directory that has a mod file. And that modules file, go.modules file, but here's a thing we could do. If we edit that modules file, just,
And I don't think edit is working, but we can. I don't remember here. Let's try. Edit mod.
go.mod.
Sorry, hold on.
I think you can say
go.
I think you can say go space mod space edit.
Like this?
Yes. Oh,
Some
help. Maybe it doesn't know about the editor.
Let's open this directory, which we are in here. So I don't remember those commands anymore because also they changed a few things since I was. So let's see if we are lucky. We'll open it from here. Hold on, no. No, not this one. Sorry,
Do you use VS Code?
No, I have it installed, but I'm not using it. Let me do something else. Okay, let me do this instead.
You can even use Notepad.
Yeah, I can. Yeah, you're right. I forgot it. See?
Well, that's interesting. What's that file?
It's what have we opened? Sorry.
Some other file.
Yeah. Holy shit.
Whoops. No biggie.
Okay, let me try again.
I think if you just go to your command line and you say notepad space,
Ah, yeah, you're right.
And then-
it's notepad, not edit notepad.
and then I think go.mod.
Yeah. Oh, sorry.
Yeah, no, I'm the master of the cheap editor. If it's a fancy
It's
editor
always
that
there.
costs
You-
money, I don't know how to use
But
it.
if you remember, once it was edit something, and it will open those editors.
Wait, is that a kitty? Es un gato.
We
Oh.
should invite the
We have a friend in the studio. Oh, no, it's okay.
Entra para allá. Pasa, pasa y saluda. Pasa, pasa.
No vas a decir hola? Hello.
Hello,
Hello, everyone. And what is your cat's name? ¿Cómo se llama tu gato?
Susie.
Zizi? Uy, pobre tiene.
Precioso.
Oh my God, so cute.
Cats and robots.
No quiero volver. No, sí. Uy, sí. Oh, es un poco tímido.
Yeah.
We have to stop things for a cat, my friends. I mean, bueno, gracias por visitar. Uy, pobre Tina.
cosa, qué cosa.
Qué suerte. They're so cute. Oh my God, I love cats. Okay, sorry, what were we doing? Oh yeah, we were coding. Okay, so if we look at the Go module file, we see the first thing it says is the name of the package. It says module, and then this is the GopherCom. Then below that, it says Go, and then that's the minimum version of Go that this package would need to support, right? So then when we go and we add those files, it should add them automatically to the Go mod file, right? If we were to take a look at the Go mod file and a different example, right? If we go over to, this is how it was working for me on Linux. And if we go into the sensor directory Arduino, and if we say go get, and then tinygo.org x drivers, it should have added it to our Go mod file. And we see it actually modified the Go mod file and added it as a requirement.
Okay.
So I don't know why that didn't work the way you expected it to on Windows, but it's probably relatively easy for us to just type that in.
Okay.
So you have to put it in below the line of Go.
Ah, okay. So behind the line of Go and require.
Yeah, so require, you've heard that one before from Python. Require space tinygo.org /x /drivers, and then
Space. So
you could put in the version or the tag or whatever, or I think you could just leave it blank.
then we leave it blank.
I believe you can just leave it blank.
Okay. So I guess we are.
So if we exit this,
Yeah, I leave it, but just in case.
and then if we try now to go mod tidy,
Go mod.
tidy, like to tidy up.
Tidy.
Exactly.
Okay.
Go mod, wait, let's go to your computer. There we go. So go mod tidy should update all the files necessary. Go, errors parsing go mod.
Another dependency.
All right, so we didn't edit it quite correctly. So let's go back to the notepad. So you need maybe some extra lines, first of all. Also, it looks like it did need the version.
Ah, okay.
So if we go back to the end of that line and we type v
0.16.0 and we new line.
and then we save that. Make sure you save it.
Yeah. And try again. Tidy, right?
Mm-hmm.
It's doing something.
Okay, so this should be fetching down the module. And now it actually is. It's pulling down all of our dependencies.
Oh,
And there is a there was an error in one of the samples, but it won't affect us right now. So we should be able to, if you say, if you type the go.mod file now, type space go.mod. So if we now type go.sum,
Go dot.
type the word type,
Sorry, go.
the word type,
Sorry, like this.
forget go, no go.
Oh, sorry.
Just the word type, space, and then go.sum, which should be the checksum of all the files that we just installed. Go ahead. And it didn't actually generate the file. But it looks like it did install our dependencies, so it might have worked. Okay. So let's go and try to compile again, because we'll deal with these other dependencies are for a future step. So if we go back to the TinyGo build, exactly. So that hopefully we'll know no. Missing go.sum entry. Okay, so let's go fix the problem with, if we go over to my computer here and we see there's some older code here that's causing this to occur. So if I go and I look to see which one of the examples, it's probably step like 5, 6, or 7. It's not 5. Yeah, here we go. So this Conocchio Ninja, Daniel Esteban, who's one of our team members, he was the original creator of TinyDraw and TinyFont, which is what we use for the displays. But since that time, those projects became part of the TinyGo organization. So we need to put these in as tinygo.org/x tinyfont, or else it can't resolve our dependencies. And so I will fix this, and then you should be able to just pull down an updated version from the repository, and it should work. So let me go and update my, again. So if I go in here and I say go mod tidy, it should update the various dependencies. Downloading Conocchio Ninja Tiny Font. It must still be in there somewhere. So we don't want tiny font. We only want tiny font and TinyDraw from the correct repositories, which is the TinyGo organization. They got moved after the time that this workshop took place. And I think if we just, that should have worked. Well, let's see. Still somewhere in there. Which program was it? I wonder. Oh, I know why. Because we actually have the fonts in here. And this needed to be updated as well. This is an actual rendering of the font as it's displayed. TinyGo.org. Okay. Go.org. X tiny font. Okay, that's where that keeps pulling that from. That's why I can't find the right. It keeps thinking that it's in there. Well, there's still another one. Does not contain package. Oh yes, because this step 7 also got changed. Only now are we getting to the point where some of this stuff are we catching up here. This would be drivers net MQTT. Yes. We moved a few things around. Okay. So now it should be fixed up. So now if I just add everything and I say git commit, and we'll say mod update references to match latest, TinyGo, and friends. And if we push this, I could have just done it from the root directory. Git push origin master. Still in the master as opposed to a main branch. Okay. So now if we go over to, and if you go up 2 directories, so just cd, cd dot dot / dot dot. So now you're in the main directory for TinyGo, and so git status.
Doesn't connect to my. Okay. Yeah, it's in there.
So you've made a few changes, right? So, but we don't care about those changes. So now if you say git reset space -- hard,
Okay.
that will do a hard reset and wipe out the changes that you made.
Oh, good. Okay.
Okay, so now if you say git pull
Well.
space -- rebase, because we don't want to merge commit, space origin,
Space.
I mean pulling it from the main repo, and then master. This will pull down the latest master branch from the remote repo, from the origin, and it will rebase it on top of our current branch. So that should do it. That's one of my favorite commands. Okay. So now we have the right go mod and go sum file because I checked those in. So if you change directories back
What was the name?
to sensor,
Sensor Arduino. Arduino.
That's it?
That's it, yeah.
and now up arrow to wherever that last command that failed was. That's it.
That's it. Okay. I go. Much better.
Okay. So now all we have to do is flash it
No news.
with the
good-
bossat command.
Good news. Let me pick the.
Exactly. Go to the mind map.
Exactly. So it's bossat port offset. We have to change step 4. Sorry.
Exactly.
And step 4 dot bin. Right?
That looks like it.
Yeah.
We probably have to tap the button to put it in bootloader mode for this, though. I don't remember. Let's find out.
Let's try. I go and we'll see. No device found. So yeah, like, how was it?
Or was it on COM? We changed it to COM 10 actually.
You true.
No,
No
still
device
didn't. Well, we have
found.
to. We do have to double tap.
1, 2, 3. Let's see.
Maybe it is 11.
11.
This one goes to 11.
Let's try again. Now that we reset. No. How was it? The other day we did something.
And we went into the device manager.
Was
And it appeared under ports, I believe.
Yeah. It's 13 now.
Oh, now it's 13.
Let's try.
That's more like it.
Yeah, this is looks good.
Okay, so now it should be running. So what happens when you push the button?
Let's see. The button. No, the normal one. It should still. Oh. Yeah. I mean, this is the same behavior. Now we should have this extra. No.
Yeah, if you want.
Okay.
Oh.
Oy, scary.
It works.
Morse code.
Exactly.
Yeah. It's beautiful.
London calling.
It's very funny. I enjoy this.
The Clash, still the only band that mattered until Rage Against the Machine.
Oh,
Yes, very cool.
fantastic.
All right, we made some progress. So let's see, what did we do? We did a bug report. with the issues with TinyGo Flash on Windows and BOSAC, you wired up the step 4. We updated the repository so that it's got the correct set of dependencies, so you were able to actually install it, and it even works.
Fantastic. One thing I want to ask, next time maybe if you have time we look at the driver or things like that, if you don't mind, okay? Would be, well, if it's not too complex stuff, but just to see, since this is a simple device, maybe...
Well, let's take a look right now, just because I actually wanted to do something on another driver. So let's take a quick look here at how drivers work. So the TinyGo drivers repository is a separate repository that, well, let's bring it up in GitHub in the web interface. So the TinyGo drivers repository has, how many? 65 different devices currently supported. Temperature sensors, accelerometers, light sensors, displays, more displays, servos, all sorts of things. And so the way it's organized is we have the drivers themselves, and then we also have examples that show how they're used, right? Like if we look under buzzer, we'll see a very small version of an example using the buzzer, where it's very similar to what your program was doing. It was configuring a pin to use, an output pin, telling the buzzer to use that, and then calling some functions of the buzzer, in this case buzzer.tone, which knows how to play a little song.
Okay.
Although it doesn't sound that great because, I mean, it's only a buzzer. So if we go and we look at the actual repository's buzzer directory, we'll see that in there we have 2 files. We have buzzer.go, which is what contains the definition of the buzzer itself, and then notes.go, which is the definition for each of those notes, which what's the hertz that corresponds to that, right? So if we look at buzzer here, so we'll see that instead of package main, it's using package buzzer. Since in Go, the package name tells us what's the name of the package to be used, and this is a package that's meant to be used from another package.
Okay.
Right? So it's called package buzzer. That way, in your program's package main, it could load
We'll call buzzer.
the buzzer package. Exactly. So it also has imports. The machine import that we talked about, the machine package, which is the hardware abstraction layer. And then the time package, which is the standard TinyGo time package, or Go time package. So then we have a type.
Yeah.
So in Go, types can be simple types like integers or floats, and they could also be struct,
Like C.
a struct like C structure. And a struct has different members, which are or fields. So in this case, we have 3 fields. One is called pin, and it's of type machine.pin. So that's how we keep track of which pin it's being connected to. Then we have a Boolean value high, which I gather is whether it's high or low.
Okay.
And then BPM, which I think is beats per minute.
Yeah.
That way, if you're trying to make it play back, I don't know how well that really works.
So the fast, the higher, let's say, the frequency, I guess.
I guess it would be more like the faster that it plays back.
Yeah,
It's got some kind of playback mode.
Okay.
So our new function, because it's not an object-oriented language, right? It's a package level function. So it's buzzer.new. And it returns a device. So in this case, it's returning a struct type of struct device, or struct of type device, I mean.
Yes.
And it's filling in the fields for us. Pen is equal to the pen we pass as the parameter.
Okay.
And then the other ones are being initialized to default values. Now, if we wanted to change these values in Go, any field that's capitalized is public.
Okay.
And any field which is lowercase is private.
Okay.
So we have no way to change pin from the outside without some type of, accessor function. But high and BPM, you can change at any time,
Okay.
right? So just an important thing to know. That is also true with functions. So this function on is exported so that I can say buzzer.on. But if it was lowercase, then that would not be exported, and so I wouldn't be able to call that from another function. So that's how we can define our interface that we want other packages to consume, and our implementation, which is how we do our own work, but we don't necessarily want other packages to worry about. So the function that we used, was it on? Yeah, so on just turns on the pin just by turning it on, and then off does the same. But if we want to produce an actual tone, that's where we can pass it the hertz and the duration, and it will do a calculation based on your typical speed of what the tone is, and then it will turn on and off quickly to generate, kind of a simple pulse width modulation style tone.
Okay.
So it's not the most sophisticated,
But
it does
works.
get the job done to, make bleeps and bloops.
Fantastic.
So that's how the buzzer driver works. Now, it turns out there's actually a much better driver for creating sound. It's called the tone driver. And the tone driver is one that was created recently by Ika, who's the actual founder of the TinyGo project. And it uses pulse width modulation, and it can use direct memory access. So it can produce much better sounding tones, and it doesn't require the microcontroller to be busy while it's doing it.
Do you need on the same kind of device like this one, or maybe on a speaker, on a small speaker, probably?
It could work on this, but you'd have to have a pin that supports pulse width modulation.
Okay.
So that's a little beyond what we're doing right this second, but we can do that in a future iteration.
Very interesting. Fantastic.
Cool. I know, it's a whole world of TinyGo.
Yes. Okay.
Cool. So
Thank you
your
very
homework for next time is the same as the last time, because it seems like we're making some progress here.
Yes. I agree.
Cool. Well,
Okay.
thanks for coming, man.
My pleasure.
Really appreciate it. This
Thank
is
you.
awesome.
Thank you very much. Great fun. Great fun.
Also, thanks so much for helping find these things that need to be updated in the workshop. Usually we do this in right before we actually do the workshop. We we got to fix these things, and we update them real fast, and then people come in and we've done this step. So this is the preparation. Thank you.
Great. I'll bring my stuff.
Yeah, because I'm going to need to get in some space here for some of the next
Let's see if this
some of the next fun.
Fantastic. Well, see
All
you
right,
soon.
cool. All
Ciao.
right.
Thank you.
See you next time. Ciao. Cool. Yeah. We're making some real progress here on improving or updating, I should say, the workshop content. So many changes in TinyGo since the last time we actually got to do a live show. Man, it's crazy. All right. So I thought it would be good to take a look at a couple of the outstanding pull requests, actually. There's been a lot of activity over the last week or so. And so last week I was trying to get a couple of tasks completed. One of them was this new pull request for the SD card support, which Sago35 has been working on diligently, and we've actually gone through a whole series of rounds of testing, but unfortunately it's not yet working. We're getting really close though. Hopefully next week. But in the meantime, Yuri Soldak, who is one of our new very prolific contributors, I guess basically went crazy, went all out, and started in on doing some refactoring of the Wi-Fi Nina driver, which, if you may recall, that's the driver that we use for connecting to the ESP32 Wi-Fi chip for doing Internet of Things style things. And so they were working on, if you recall, a couple of weeks ago, the Wi-Fi Nina driver was desperately in need of some tender loving care, and a couple of different people had done part of the work to get it there, but it needed a really big push. And so they went in and got it all basically to a functional state. So this week, was that yesterday? Yeah, 19 hours ago, they took a look and they said, wow, can we make this smaller? Like, can we shrink this down? It turns out that if you use the format package, the FUMT package, which is part of the standard Go packages, that the FUMT package needs to use reflection. So reflection is a capability where a program is able to look at itself, information about its own operation, metadata about the program, and then using that, make some decisions about how it's going to execute at runtime. So in Go, this is commonly used as a way for parsing JSON, since we may be receiving an arbitrary JSON document with different fields and different data. So the FUMT package, which is part of the Go standard library, happens to use reflection. And using reflection in TinyGo requires increasing substantially the amount of memory that we need, because we have to include a bunch of code that, if we don't require reflection, we can get around and we can actually optimize out so it's not part of the final binary. So Soldak took a look at this and said, I bet we don't need the FUMT package. And so these were their results. So the original example with the original driver, 55K. Okay, not too bad. New example with the old driver, because the old driver still requires the FUMT package, 55K. Okay, so it still dragged in that dependency and it still required it. But the new example with the new driver, only 30K. Oh yeah, I like it. That is a substantial weight loss program, apparently highly effective. So let's take a look and see if this actually works. Because if so, I'm merging this right away. This is totally awesome. So first thing we're going to do is we'll check out. So let's go over to our drivers repo directory in our command line. And let's make sure that we git pull rebase origin dev to make sure we have the latest. Oh, I have some changes. What are those changes? Let's stash those changes. Okay, so we'll pull. All right, good. Let's see what our commits are that we pulled in. Yeah, here's the. Oh yes. Okay, so these are all the latest changes that are in this dev branch. So now if I git checkout -b for creating a new branch, so it's going to create a new branch with this name soldak Wi-Fi Nina avoid FUMT, and it's going to create the new branch based on the current dev branch. Okay, so far so good. And then now we're going to git pull, except we're going to also say git pull rebase, so we don't add the merge commit. So we're going to say git pull --rebase, the name of the repository, which they have called TinyGo-drivers, and then it's going to pull down this branch, Wi-Fi Nina avoid FUMT, and it's going to rebase it on top of our current dev branch. Okay, so far so good. And then if we let's go and let's take a look and see what we got. So in the driver's repo, under the connect, we will see that there is, this is actually now is using strconv, string conversion, instead of funct. So if I get rid of this access point info here, because that is actually, I put it into a separate file. So now I should be able to test this just by building that, right? But of course I'm going to need to get my chip, pulling out my, get a little focus going. So this is my Arduino Nano 33 IoT. There's the Wi-Fi chip in question. So if we plug this in, so we can flash it, and let's plug it in here to the computer's USB port. Okay, very good. And then, so now what I want to do is I want to say TinyGo flash, and now I'm going to use size short. What is that? So that outputs, that's not the size of the program. Maybe that's not the best named flag, but we couldn't come up with another name. That is going to output the short version of the statistics for the build, which is how we're going to be able to see how large the actual file is, how much RAM and how much flash it takes up. So TinyGo flash size short, target Arduino Nano 33, right? And then we should be able to say examples Wi-Fi Nina connect. And that should, and yeah, 30K. It's really small. All right, so let's go over to my terminal somewhere here. And let's see if we can connect. Connecting to the Hackspace. Trying to see if it can connect to, yep, it connected. That is the SSID. There's our relative signal strength indicator. The MAC address that is on the board, that the Wi-Fi Nina chip, the ESP32, the IP address that was assigned, the subnet, and the gateway. And that's our time. And yes, it is today. And it is 1600 hours UTC, which is 1800 hours Central European time. Wow, cool. This seems like it's actually working. Amazing, actually. I mean, seriously, that is so cool. If you can chop off 20K of a 50K program, oh, man, I love you. That is so awesome. I can't wait to merge this. This is just like, anything that makes TinyGo smaller, to me, is miraculous and useful. So let's merge this in. This is great. This is really great. It's not just great. Thank you so much for making things smaller. Now merging. And it's going into the dev branch. So yeah, looking pretty good. Rebase and merge. Yes. Oh man, that is so cool. I love making things smaller. And I love when my new internet friends make things smaller. That is great. Especially 30K may not sound like a lot, but it's pretty substantial. You know, if you want to use, I know some people would like to use the Wi-Fi Nina driver with an Arduino Classic with an AVR processor. I don't know if this is going to make it work, but at least it's going to start getting you down into the size of binary where it's even possible. Just because when you have such a small amount of RAM, knock off 20K, maybe we're in the range now. So I guess we'll find out. That is really exciting. Cool. All right. So there's another thing I wanted to actually work on that a bunch of people have been talking about, and we talked about it briefly last week, which is this outstanding pull request new outstanding pull request for adding support for the Raspberry Pi Pico RP2040 microcontroller. So, as you probably are, if you've been living on another planet even, you probably still have heard about the new Raspberry Pi, which is the first actual microcontroller. It's not a single board Linux computer. It is the next smallest thing. So this is one of the Raspberry Pi Pico boards from the first production run, which I got sent by Raspberry Pi, and it's lacking a board here, which is the new Raspberry Pi Connect, which has just come out, has on it an U-Blox ESP32 Wi-Fi chip is right here. So you can see where adding Wi-Fi to this makes it even cooler, right? So anyway, this work has been going on for a while to add support for this cool new board. Several people worked on it and got it partway along. And Rhythm Crazy is the lucky recipient of got it to the point of where it looks like it's actually ready to be merged in, right? So if we take a look and we see there's been a lot of work that's gone on, and several people, even Y Soldek has confirmed that it works. So yeah, that's all looking pretty good. So this pull request actually was a bit more complex because it had to add not just your usual support for new registers and new hardware compatibility, but it also needed to add support for a new SVD file. So SVD files, let's see if I can find one to show you an example. So SVD files are the system description files originally created by ARM and now, really sort of turned into semi-standard. And I believe there's one in here. It's SVD, not SVG. SVG are graphics files. SVD files are the system value description or system version. I forget what the V stands for. But it's no, that's not it. Let's see. I want to show you one just because it's pretty impressive. Let's see. Source. Maybe. Yeah, here we go. View raw. It's so big, it's raw. Here we go. It's a giant XML file. No, I mean, it is a giant XML file that contains all the descriptions of every single register in the entire processor, along with actually kind of a description of what it does. And so this is what TinyGo uses to actually generate the files that are used for the device package, which if we take a look at the TinyGo documentation, if we look in our concepts, I believe, we could take a look at this mermaid diagram that shows us that what I was just talking about, the device package is generated from those SVD files. And that is what the machine package, which is the hardware abstraction layer, uses to know how to communicate with this very low-level hardware. Right? Cool. Get the idea. So we had to actually add that file to our repository that we use upstream of SVD files, as well as all the other work that had to be done to add all of the definitions for the pins for the board, the initialization for the different clocks, for the GPIO. So let's go and see if this actually works now with all the latest versions of the dev branch. So if I go over again to my command line instructions. Oh, it's my son. Oh, missed the call. I was going to bring him into the stream. Darn. Okay, well, next time. He'll probably call back. Dad, I need help with my homework. Okay, so where were we? Oh, yes. So let's first, we'll check out. Let's go to our TinyGo. And so if we say git checkout -b for creating a new branch named rhythm crazy -pico and based on the dev branch. Okay, so far so good. And then we'll do a git pull, but we'll also add -- rebase because we don't want to merge commit. All right. So git pull -- rebase, and then the location of Rhythm Crazy's Git repo. And so we're going to pull that repo's Pico branch down, and we're going to do a rebase onto the current branch in my local directory. And it did work. All right. So now if we do make, which should build our latest binary of TinyGo, which we need. Actually, let's interrupt that, because before we do that, so we need to make sure we've got the latest versions of our submodules. So I want to say git submodule update init, which will pull down all the latest versions of our submodules. And actually, we already had them, so we were okay. But it's always good to make sure. So we'll do git make, and that will build the binary of the TinyGo compiler itself with all of our latest goodness in there. And then after that, which it just takes a little minute because it's very good. So we need to copy that. And now let's run TinyGo version. And you see that it's the 0.19.0 dev, and 71CB is the last commit, and so that should correspond to where is the files I'm expecting from the what I just pulled down? Because I did do the git pull rebase down from Pico, and that should have pulled down those recent changes from I'm not seeing them in there, because the commits that we should be seeing, oh wait, there's only one commit. I see, it's just one giant commit now. There were a few commits before. I see, so it's 88E7. So let's go, and there's probably some other commits after it. Let's see. I'm not seeing it. That's kind of weird. Wait, there we go. There's the commit right here. And we can see it's got all those files in there. Okay. So it is, we do have the file. So now if we say make gen device, so make gen device runs the Go program, which actually uses all of those SDV files and generates all the wrappers. And you'll see it did all the Nordic Semiconductor, and right now it's doing all of the Atmel AT-SAM boards, and it already had done, right before that, the ExpressIF boards. So there's a lot of SVD files for the many, many dozens or hundreds of different kinds of processors. So we needed to have that update, and let's see. That was updating the Kendrite RISC-V, and there's the NXPs. Here come the STM32 boards. There's a lot of boards. We don't have support for every one of these boards in TinyGo, but we have quite a few. Not even a fraction of the total sum, though. There's so many boards. All right, and then I was expecting it to do, well, we did it anyway manually, make gen device RP, and now that's built the Raspberry Pi 2040. Okay, so now we should be able to go TinyGo, flash, target, I want to say Pico? Let's go and look and see. What's the name of the target? If we look in the .json file that corresponds to the target for this board, down here at the end, we'll see that it's actually named Pico. Yes. Okay, very good. Target Pico. I guess size short, so we can see how big the file is. And then let's do examples, Blinky 1. And now we need to naturally plug in the board. So we'll plug it in to the USB, and then the UF2 bootloader should be able to take effect. So now if we go back to our, this is our command, and 4K program, it failed to flash. Unable to locate device RPi RP2. Okay. Usually that means that the name of the mass storage device is not what we expected it to be. So if I double tap the board, which should kick it into the bootloader, it's supposed to. I thought it would, but it's not doing it. Okay, interesting. I thought that was all we had to do. Well, let's see. Did we have any mass storage devices that mounted? No. It's not boot. It's not kicking into the bootloader. Not off to a great start, but let's see. I thought that's all we had to do was double tap it. That's what we normally do. Let's go and take a look and see if anything... well, let's just try to run it again. Nope. Okay. Let's see. I thought that's all we had to do was double tap it. So let's see. Raspberry, Pico, bootloader, double tap? I don't know. Maybe we have to do it real quick after plugging it in. Uh-oh. Not off to a great start. I don't think it has to do with the pull request, though. It's just like the board itself is not responding. It did solder this board earlier, but I don't think that would affect it. Generally, no. But oh, you don't double-click reset. Instead, hold down boot select during boot. All right. Yep. I heard the noise. There it is. Okay. So it mounted. I don't think I think the part that's not working yet is the part where it kicks it into the bootloader. Okay, so that time it flashed it. And now we can see that, in fact, it is blinking. Okay. So it looks like in order to get this to work, we're going to have to boot it with the button turned down. We don't have the 1200 baud port reset that we use for flashing other boards yet. So it's not perfectly convenient, but it does work. Wow. Okay. That's actually pretty incredible. So a lot more work needs to be done, but that is a very substantial bit of progress. And I'm not really sure that we should try to do anything more on this pull request before we merge it, just because it's been, so long in coming, and there's also a lot more work that needs to be done. So I think we should merge this as it is, and then we can proceed from there. So let's, so this was actually the original work done by Jeff M. Hastings to end up with this. So let's just get it in. So tested. And appears to work as promised. Thank you, Rhythm Crazy, for getting it ready to merge. And thank you, Jeff. Where is it? I think it's Jeff M. Hastings. Yes. It is Jeff M. Hastings. And thank you, Jeff M. Hastings, for getting so much done to get it started. Now merging. Woo! Oh my God, incredible. I mean, there's still a lot of work to be done, but that is substantial progress. Wow. Pretty incredible. So let's check out dev. And let's get pull rebase origin dev so we can get that in there. Wow. Unbelievable. At last, minimal Raspberry Pi support. But minimal is just minimal, right? Like, that's just a start. So what I thought we could try to do, we don't have a lot of time, but we have a little bit of time. Let's see if we can add a bit more support, like maybe for the digital in, not just out, right? So first thing I thought we would do is we could try to finish soldering up this board. The pins are not actually soldered to anything. They're just sort of hanging loose. We could see that on this camera a little bit better. I started doing a little bit of soldering on this before, but As you could tell, I didn't get that far before my battery-operated soldering iron ran out of battery. And because my good soldering iron was down here at PIPA, so let's just do a little quick solder job on this thing so we can try to plug in some other devices like maybe a button, right? So I got my soldering iron here, and it's a pretty good one. Gets nice and hot. I got my sponge, which I wet down so that I can try to clean the soldering tip. And I brought a chair, which somebody took. Oh, no, it's over here. They didn't realize I actually needed this today. They thought I was going to sit down and start playing some keys. That's also fun, but there we go. All right. So let's take a quick look here and see if we can just solder it up. So let's turn on the soldering iron. I got my solder. And we can see that most of the pins are not soldered. So we're going to have to do this real quick. There's a bunch of pins, but I'm generally not too slow. I mean, I'm too slow to work in a factory. I would definitely get fired like my first day. But, and we got the temperature here, so let's turn it up to maybe, I don't know, 5, 6, pretty hot. And we can tell it's starting to work because a bit of smoke will come out off the tip. It's making a little hissing. You can't hear it over the fan of the computer doing the streaming, probably. Starting to heat up. So we'll use some solder to clean the tip. I have something better to clean with, but I don't want to look for it right now. And then we'll wipe that off. You want a nice shiny tip so that you can have a nice clean solder joint. Otherwise, a cold solder joint will not conduct electricity very well, if at all. All right. Good. Looking good. Turn it down a little bit. All right, so let's just heat up these joints from before. Okay, it looks like it's still straight, so we'll go for a quick series. I like to do one right after another. There we go. Once it gets hot, then it works well. But if it's not hot enough, generally it won't solder. Got a little too much on there. Get this cleaner. It's been a while since I used this particular soldering iron, so there we go. Now it's nice and clean. But I think it turned it down too much. Let's get it a little hotter again. If you get the right temperature, it works great. If not, well, let's just say all right, now it's hot enough. All right, so let's do this. It's not really getting quite hot enough. There we go. Once it gets hot, it works great. And the solder will just sort of flow. And then try not to inhale the smoke. Don't inhale, man. Okay. Almost halfway there on the first side. Cool, cool. We only have to do this once, luckily. Alright, almost there. Now you can see why I could never work in the factory. Actually, I do work in the factory sometimes, but not soldering things, let me tell you. Well, first of all, this is not how they do soldering anymore. They use ovens, and they solder all of these joints all at once, very, very quickly. I don't have a reflow oven. Now, I know some people have used like a toaster oven to make a reflow oven, and I would like to do that as well, but I don't normally do that many soldering of surface mount components. I generally use through-hole components. So, okay. And then let's heat these up from before so that they're a little shinier and nicer. Okay, we're done with side one, now side two. And when it flows in there, it just pours right in. Yeah. You need a second light. And when it, yeah, there we go. Now you can see it. I'm used to soldering in the dark. You can see it just kind of pours right in there. Once the pin gets hot, solder pours in to fill the hole, and then you have a good connection. That is really important with these digital electronics. All right, just a couple more. We're almost there. One more, or actually two more. And then let's go and fix these so that they're nice and smooth. And then this one. And then let's just go get this one here. Looks kind of not so good. Oh, can't connect them. There we go. All right, that's it. We're done. Clean off the tip. And turn off our soldering iron. And everything is nice and even. So then I just need my breadboard, brought for this exact purpose, and we will plug it in so that the USB is coming out the top, and so that there's 2 pins on each side for us to plug things into, and make sure it's all lined up, and then push it in. And if we haven't destroyed the board, when I power it up, it should start blinking again, right? Oh, we got to plug it in on both sides. And it still blinks. Okay, so we didn't kill the board. That's good. All right, so now let's see if we can take a quick look at what we might need to do in order to add the GPIO in. So first thing let's do is git checkout -b, and we'll say RP 2040 GPIO in. Whoops, I didn't mean to name it that. GPIO in. There we go. And let's get rid of that extra branch. Git branch -d RP, and then what was it? This bracket? There we go. All right. So I took a brief look before at the data sheet. So data sheets are very long documents, usually in the form of a PDF file, that are distributed by the manufacturers of processors and boards. This one is 647 pages, so it's, decent size, not the largest by far that I've ever dealt with. It's amazing how quick you can read, 500 or 600 pages and scan through. So it's got a nice red cover. And the table of contents here tells us all about the different capabilities and peripherals and blocks, as they're known, because they're literally blocks of circuits that are on the surface of the wafer of the chip. And so if we take a look, for example, at the pinout reference, you'll see this is the pinout of the chip. Now, you might be wondering, what does that weird-looking square thing have to do with this actual board, right? Well, this is the pinout for the chip itself. So not wherever the leads are that the chip connects to on the board for whatever pins. These are the actual pins directly, the GPIO ports on the chip itself, right? So if we want to know what's on the board, then of course we have to take a look at some picture that shows the pins on the board. Naturally, the Raspberry Pi, like a bunch of these boards, the silk screen that labels the pins is on the bottom side of the board, so we can't actually see it while we're using the board. So that's a little annoying, but not totally surprising. So if we took a look again back at the table of contents, we could see that it's got the power supplies, the memory, the power control of the chip, the different oscillators that control the timing of the chip and its different peripherals. And we'll see that it's got the GPIO, which is the general purpose input and output pins on the chip. So let's go take a look at the actual code that we've written, or that's been written, since I haven't written any myself quite yet. And if we go take a look at the machine package, and we look at the RP files that we just merged, wherever those are in here. Oh, one thing about sometimes Visual Studio Code doesn't like when you update very large files, so it can't refresh anymore. It actually tells you that when you first run it. Like this workspace is too large for us to refresh or something of that sort. Anyway, let's go back to the machine package, and now we can see our RP. And if we look at RP 2040 _ GPIO.go, you'll see this is listing the different registers and that are being used for the different parts of the PIO chip. So it turns out the Raspberry Pi RP 2040 is not just your garden variety type chip. It has a separate chip called the SIO, it's not PIO, sorry, the SIO, which is a special separate I/O coprocessor. So it actually is able to do very fast processing because one chip is doing just these peripheral I/Os and the other one is coordinating all the work. So this SIO chip is a multi-purpose I/O, so it can be used to do not just your general GPIO for turning things on and off, but we can also use it for other interfaces like the SPI interface, which is the serial peripheral interface that we use for things like displays, the UART interface that we use to communicate, text with your terminal, etc. Right? So let's go back now that we know that again to our definition in the TinyGo board or machine file. So we'll see that this is talking about the different function selectors of being able to choose on that SIO what is the function it's going to perform, right? Whether it's going to be, as we were just looking at, the SPI function or the UART function, the I2C, or in the case of what we mostly care about right now, right, which is the PIO, I believe the peripheral IO, or the, so let's take a look here. So we've got our pin mode for output. We're going to need to add one for input. So pin input. So that gives us a pin mode that we can switch to. All right, so far so good. And then these are some functions that are used for the set. This is the set itself. And we can see that the way it actually works is it takes the pin number and then it bit shifts that position, because the way that these pins often work, and we can see if we go and look at the data sheet, this will actually tell you that each one of the pins has a position, a bit that corresponds to, or each one of the banks has a position that corresponds to that one particular pin. So pin 0 would be in the 0th position, pin 1 would be in the 1 position, and so on. And so if we go and we take a look, we can see that's how this set function works, is it says set bit 1 on to whatever bit corresponds to the pin we want. So if it's pin 0, it'll set the 0-bit position, so it would be 0000001. And if we want to turn on pin 1, it would be 00000010, and so on. And then based on that mask, meaning which bit we want to turn on, it uses the SIO register, or SIO block, I should say, is GPIO out set register. So this sets the pin to on. And then this clear does the opposite. It's to turn it off. It uses the same SIO register, but now it uses, or block, I should say, but now it uses the GPIO out clear register, and it sets that. So I know it seems odd to set something to clear it, but that's actually setting this bit actually turns off the voltage to the other pin. And then we have an exclusive OR, which is to leave all the other pins in their current state and only turn on the pin. So turning on or off the pin. If it's already on, it'll turn it off. And if it's already off, it'll turn it on. So flipping it, essentially. And then we have a couple of helper functions, which are, this sets the function as we were looking at the list of functions that are supported. And so this turns that function on to whatever pin function, which I would assume, let's go and look and see what that is. Set func. And so we're using the SIO function. In other words, this multi-purpose ability of the block where we can use it for GPIO or I2C or whatever. So we're telling it, use the SIO function so that we can just treat it like a normal GPIO. And that's what this init function needs to do. Okay, so far so good. So then our configure function, which is what we normally call when we're programming in TinyGo. If you remember our blink function where we had to declare a pin and we had to configure it to be output, well, this is where we actually do that work. Right? So in this case, we already have output, so we want to say case pin input. And what should we do when our pin is set to input? Well, I will guess that instead of output enable, this looks like GPIO output enable set. I will guess that it's input enable. I'm just guessing. Let's go take a look and see if there's a GPIO IE set in the datasheet. So this is setting an IO function using a GPIO interrupt, which we're not quite ready to do. Let's go back up to the top here of the list of functions for GPIO. Actually, I think we need to be in the SIO function. If we go down here to the actual PIO overview, because we're using the PIO function directly now, right? And we look at our, no, we are, we're using the SIO. That's right, not the PIO. So let's see. GPIO control. And then we have our GPIO output enable. And then we have our GPIO N. I think they're default to input. And they only turn to output. That's what it kind of looks like. Because we see that there's GPIO output enable clear. That's if we don't want to use it as an output. So we probably need to do that, right? Like, we probably want to not use it as an output if we're going to use it as an input, just in case it was already set. So we would want to say GPIO output enable clear, I believe it is. CLR, yeah. Because I don't see an actual input enable. So I will assume that if we turn it off as an output, then it's no longer an input. So that would be output enable clear, CLR. And we don't need to set it as input. So that should presumably set it as an input. Right? Looks like so far so good. I don't know what I'm doing, but I'm making it up as I go along. Pretty sure that usually that's all you have to do is that. So now the last thing we're going to need is we're going to need to write a get function. So get reads the pin value. And so it's get, and it doesn't take a bool, it returns a bool. And so now here is where we have to actually retrieve that. And then, I guess return p.get, essentially. Which we haven't defined that yet. But we will right now. Right? That way we have a little wrapper. So get should look a lot like set. And we'll put it at the end of those other functions. And so get returns the pin value. So it's get. So now what are we doing? So we need to set a mask, right? And there's actually an example of this in the data sheet. We say, I believe it's up here with these code examples. Clamp mode, no, that's just something else. Let's go to the top because I'm pretty sure it's listed in our table of contents. There are some examples. Even says examples. Let's see. GPIO. There we go. And it even shows us, where are they? Here we go, software examples. All right. So set an IO function, we already did that because we know we need to choose the SIO, right? And we don't want to enable an interrupt because we're not reading an interrupt. And let's see if those are the only examples? Because I saw it in here. Let's see. GPIO get, or maybe just a get. I know it's in the. I ran into this before, and I was just sort of gazing at the datasheet, going, "How am I going to find this again?" Let's see. I know it's in here. I thought it was under software examples. No, that was what we were just looking at. Let's see. Peripherals, no. PIO, no. That's funny because I was just looking at. Isn't that the same list of examples? SSI. And I was literally just looking at this example. There's two sections of. I was just looking at it before. Let's go. Let's just look at the code and see if we can kind of guess. Because it's GPIO in, I believe. And that would be get. Because what we want to do actually, no, we want to get the value. And then we only want to, we want to get the value and then return only the bit that matches the pin that we care about. In other words, if we go and we take a look at the SDK, we can see an example of that in this, I think it's RP40, no, RP2 common, hardware GPIO, and I believe it's in here that we can see an example of this very function. Here we go, GPIO get function. And that is the function we're looking for the definition of. Let's see. Is this it? Yeah, here we go. So we want to look at the hardware GPIO control. That's not exactly what I was expecting. I know what we need to do is we need to look at the register. Let's go back to the top here. I swear I saw exactly the code for this, but maybe it was in here. Anyway, go back to the data sheet because we're almost out of time, but we can at least take a look at it. We can see that the GPIO registers that we are looking at, if we scroll down a little bit here, not the interrupts, not the pads, but we can see what we want to do is not set function. Get, if there's a get in here somewhere. Here's the registers. So we can see that we want to read the GPIO, I want to say in. That's worth a try. GPIO in. Yes, here we go. So this is an example of what we want right here. We can copy this function. I mean, we don't quite have time to implement it, but let's just take a look. So this is taking it's shifting over the bit of the pin we want, and it's comparing that to the value of the SIO GPIO in, right? So this val, we want to take the value and we want to shift over val, because that's which bit it is. So we want to basically test to see is val's bit, or actually we could even just say it even easier. We could say has, let's say has bits, and then one shifted over P. So this is not exactly correct, but it's almost correct in that what it's saying is, does this register have a bit set in that bit position? So I'm not quite done with this, but I'll see if I can finish it up this evening. We're pretty much out of time now. We got pretty far along. Well, so what did we actually get to do? We took a look at our state of the art. Well, actually, we heard some news. We saw that, yes, I am a true thought leader if I could only think and if I could only lead. Maybe I'm a thought follower. What's the opposite of thought? I don't know. Thought. It's its own opposite. So, yes, we took a look at some of the cool news of the world. Yeah, the chip shortages are still bad, but some people like Oxide Computer are just going to build high-end systems anyway. And we worked a little bit on our TinyGo workshop with Lorenzo and reported a bug upstream to flashing on Windows. Then we got a couple of pull requests merged. In particular, the Raspberry Pi, which we tested and in fact does work. And now I'm hopefully almost done with adding the GPIO in. So by this time next week, I will expect that I will have it done. So with that, GopherBot, what's that? The batteries? Oh no. Well, next week, more will be revealed to you, dear friends of the internet. So until then, I say farewell.
Computer Liste, Computer Liste, everybody that it does get flat. Computer Liste, Computer Liste, you put it all on, put it all on. Computer Liste, Computer Liste, everybody that it does get flat. Computer Liste, Computer Liste, you put it all on, put it all on. Computer Liste, Computer Liste, everybody that it does get flat. Computer Liste, Computer Liste, you put it all on.